Okay, I think we are live. So, hello everyone, welcome back again to our channel Coders Arcade. This is Saurav and today again we are back with our Java DSA live sessions. Okay, so let me just write it down. Java DSA live sessions. Okay, and we are at Coders Arcade. Okay. Let me just open the same link in our mobile, in my mobile, so that I can also see if you are writing any messages. Okay, so for the time being there is nothing, all good. So let's get going. Okay, as I said, yesterday we had started linked lists, linear data structures, and we had started with linked list. Okay, already we have learned arrays, 1D arrays, searching, sorting, and also after that we had learnt stacks and queues. Right now we had started linked list yesterday, and I had told you about a singly linked list. Correct, singly linked list. And I had shown you two operations, if you remember, the insert operations, or I said the add operations. So I had given you add first and add last. Okay, if I go to that code, if you see here, yes, this was our singly linked list code. Here if you see carefully, we had taken the head as a pointer and then we had taken a size variable. After that what we had done is we had actually created a node. Basic idea, right? You remember, right? The singly linked list works like this. We have a node with the data and the pointer to the next node, and we can only travel forward, the data and the pointer to the next node, and the last node will be connected to null. Basic idea, right? And we had tried to insert string data in that. Correct? And we had already done something like this, if you remember. We had taken the size. Once the node is added, we had incremented the size. See, size plus plus, and we had written a method to print the list. Got it? And then we had also done something like this. Add first to add a node at the beginning of the linked list, and to add a node at the end of the linked list. Okay. So the conditions, if you remember, add last, we had to check whether it was empty. Okay. And everywhere when we were inserting a new node, we were creating the node. This was common. I hope you remember. Guys, if someone is new to the channel watching this video for the first time, please make sure you go to the previous videos. There are lots of videos in our live sessions. Go through them. Today you might understand little bit, you might have some difficulty, but gradually when you follow the previous videos, you will understand all of them. And those who are new to the channel, one more time I am requesting you, please subscribe to the channel and hit the bell icon so that you get notifications about our latest updates. Okay, because we generally come live almost every day, barring Sunday or Saturday also. Sometimes I might be very busy, so at that time I might not be coming live. Okay, so 6 to 8 is the uh, interval during which I come live, 6 p.m. to 8 p.m. Okay, because it depends on the time I come back to office from my colleges or other trainings in companies. Okay, so after that we do this, and you can see we had created the list like this. Add first, we added Coders Arcade, then added channel, then added our. So it was our channel Coders Arcade, correct? And then at last we added has 50k and subscribers. So when we printed the list, we got an output like this, something like this. Our channel Coders Arcade has 50k subscribers and then null. That means node 1, node 2, node 3, node 4, node 5, and then node 6, and then the last one is null, because and it has only forward traversal. A singly linked list has only forward traversal as seen in the diagram, because and always remember one thing, the starting node is called the head. Got it? And the ending node is called the tail, but we don't need the reference of that one in singly linked list, but in doubly linked list we will need that. So we'll see how to write that. Okay, so right now I don't think anybody will be having any doubts because we are just starting. Okay, so let's write down the codes for this one. What is that called? The delete operations. We have seen how to insert at first, insert at last. Let's see the delete operations. Also, we will be seeing how to delete a specific target also. Suppose I want to delete the first one. Initially, in this case, the first one is hour, right? If you see the output, see, hour is the first node and subscribers is the last node. I will show you how to delete this one and delete this one, and also how to delete a specific value. Say suppose I want to delete Coders Arcade, or suppose I want to delete 50k subscribers. We will see that how to do it. Okay. So let's try to write down those codes, and while writing the code only I will explain you how everything is working. Okay. So first one, let's write down the first one. Blue-eyed boy says, "Good evening, sir." Okay, good evening. Okay. See, I'm having the same thing in my mobile so that I can just look at your comments and reply back. Okay. Because otherwise, I will not be having a track of what you guys are speaking or saying. Okay. So I'm doing it like this. Now, we need a method to do what? Delete the front node or the head, or you can also say that delete first. So based on that, we can write down a code like this. Delete, remove or eliminate, whatever feels good for you, you can write that. It doesn't matter. But the base logic is same. Okay. So I'll just say public void remove first. Okay. And I don't need to pass any data. I just need to remove the first. That's all. So first thing first, if the limit is empty, if the list is empty, I cannot remove, right? Very simple. So I will just do one thing. I might have that code somewhere. Let me write it down from there only. Somewhere it should be there. Have we not written that? Not yet. Okay. In insert operation, even if it is empty, we don't bother about that, right? So if the head is equal to null, then the list is empty. Correct? The linked list is pointing to null. That means it is empty. So S out, I can just say list is empty. Okay, and I can say can't delete the first node. Got it? And because you were not able to delete anything, just return to the main method. Okay, whoever is calling it. Understood? The first case is very simple. If it is empty, we cannot remove. Otherwise, let's see. Very important. For a single node, just try to understand. Let me draw the diagram. This is a single node. It has data and the next. But if it is single, it will point to null, right? So this is my head. Head will point to null. That means head dot next is null. Head is not null. Head dot next is null. So if I check like this, if our head dot next is equal to null, that means what? It is in list with single element. Then how do you delete this? Simply point the head to null. Head is pointing to this node. Point the head to null. That's all, and return. Right? Blue-eyed boy. आज तो मैं ठीक हूँ, आज तबीयत ठीक है. Yes, very good question. How to insert the middle of linked list? ये इंटरव्यू क्वेश्चन है, तो ये इंटरव्यू क्वेश्चंस में ही हम लोग बताएंगे. ठीक है? At that time only we'll discuss. Don't worry, मैं बता दूंगा कैसे करते हैं. It is a very good algorithm called the Floyd's algorithm. I will tell you about that. Don't worry. Okay? So what I said, for a single node, the head will point to the next node, which is what? Very important, it is null. Let me write down in the bracket null. Okay? And also for multiple nodes, actually the head will point to a next node, which is not null. Control C, I'll copy and let's paste it here. Bracket, this will be not null. Okay, hope it is clear. So in that case, let's do it for a if it is a single node, it is already pointing to null, right? It is already pointing to null. So just do this thing, head dot next, point the head to head dot next, which is already null, so automatically it will be null. So I can write like this, this dot head dot next. Okay, this is the next value of the head. Remember, this is head dot next. So I will update the head like this. I will just say head is equal to this dot head dot next. Why this keyword is used here? Because it is a variable of this current class. See, the head is a variable of this current class. So I am just using this keyword so that we can specify that I am trying to refer to that particular head variable of the current class, like this. So automatically it will go to the next pointer, or simply it will go to the null value. It will work for both the conditions. Okay. I hope you have understood this. Let's verify. Just by writing the code won't work. We have to verify whether it is working or not. So what I will do, this is remove first, right? So let's do one thing. Okay, here I will say list dot remove first, and after that list dot print list. Let's see if it works or not. So our should be removed here. Right click and run this. See, our channel Coders Arcade has 50k subscribers. Okay, here our has been removed. Got it? I hope you have understood. So guys, when you write the code in C or C++, you have to do so much things. Delete that, free the memory, all these things. In Java, see how easy it is. In one single line you have done that. It will work for single node also, it will work for multiple nodes also. In one go you were doing that. See, if it was a multiple one, see what happened actually. I'll show you what happened actually. We had our and then we had channel, right? Ours, this was the head. So what I said, this dot head dot next, head is equal to, so head dot next is this one, head came here. Automatically the linked list is starting from the second word, coders, sorry, channel. Got it? That is how it works. No comments as of now, all good, so it's fine. Okay. I hope it is clear. Guys, if it is clear, please let me know if it's clear. Just message understood or clear in the message. I'll figure out that, okay, you have understood that. Okay. I hope it is clear because it is very simple and you should know that by now. So this finishes your remove first. Similarly, let's write the remove last. Okay. Public void remove last. And obviously, I don't need any parameters here. Again, same thing. Agar empty hai, if it is empty, I cannot do, right? So I'll just copy the same thing, paste. List is empty, can't delete the last node. You can write last node. Okay, got it? Make sense? Now, not empty. Conditions. Tell me, who will tell me? Let's talk about a single element. Empty case we have handled. Now let's talk about a single element. How will you check single element? We know that head dot next is null. If my head dot next is equal to null pointer, in that case make the head null. Simple as that. See, I will write you this thing. Head is pointing to null, make head equal to null, that's all. Then we lose track of the linked list. Head will point to null, that means the data is automatically removed. Head equal to null and, sorry, not new, null, and then do what? Return to the main method. Whoever is calling that, just return there. Got it? So single element case is handled. Now multiple elements. Multiple elements. Yes, blue-eyed boy says clear, sir. Very good. Now try to understand this. Multiple elements. Obviously, if there are multiple elements, I have to traverse from the head to the tail, right? That has to be done. That is mandatory. So I will take a current pointer is equal to head, and I will just take while our current, you can write temp, you can write last, while, try to understand. very important. Can we just go and simply delete the last one? Is it possible? What will happen? Think. See what I am doing. There is a very popular approach called the two pointer approach. Let me just show you something here so that you can understand that. Okay, something like this. I have say, let's take some random values. I will take single values. Okay, A, then I have B, then I have C, then I have D. Consider them as strings only, doesn't matter. You can take numbers also, A, B, C, D, E, and then this is null. I want to delete this node. Okay, so there is a special approach called the two pointer approach. This is used in most interview questions of linked list. Okay, and this approach is also used in the merge sort algorithm. Okay, I will show you how it is. We have already discussed a little bit about that before that only. So this is my current. Okay, and I am taking one more last, which is, so I will just write like this: node of current is equal to head and node of last is equal to head dot next. We have taken two pointers, one pointing to the head, one pointing to head dot next. Got it? Anybody saying anything? Not yet. All good. Okay. Try to understand. We'll just traverse like this. I'll say while my last dot next is not is equal to null, I will keep on moving both towards the right hand side. Okay, I will say current is equal to last and last is equal to last dot next. Keep going. See what will happen, I will tell you. I need to find the last node and delete it, but I need to keep track of the previous node also, because that will become the last node later, right? That will, this is pointing to null, this one is pointing to null, but later this will point to null. That's why I need to keep a track of both of them. Okay, so for that what we are doing is, see, check this now, last dot next is not null, last dot next is not null. So current will come here. Let me take a different color. Current will come here because I have written current equal to last and last equal to last dot next. It came here. Okay. Now again check, the same loop will continue. Last dot next is not null, correct? So current will come here, last will go here. Make sense? Now again check this. Last dot next is not null, so current comes here and last comes here. Got it? Magic. We have found the last node. Yes, because last dot next is null. So automatically this loop will stop. This will stop. Okay? Is that clear? Any doubts you can tell me. Now what should we do? My current node here will become the last node. Current node dot next is pointing to this, right? Try to understand. Current dot next is last, but now I will make current dot next point to null, and automatically JVM will garbage this. It will automatically collect that garbage. Got it? That is how this code is working. Okay. So let's write it down. Any doubts, anybody? I don't think as of now there is doubt. Okay, fine. So let's write it down. Okay. While our node of last is equal to head dot next, correct? So I said while our last dot next is not is equal to null, what we are doing? We are moving the current to the last and we are moving the last to the last dot next. Yes, not minus, sorry, my bad, this will be equal to. Okay, and gradually we found the last node. What were you doing? Current equal to last dot next. Current dot next is last, but I will shift it to the last one. So I am making current dot next is equal to null. Got it? Because being a singly linked list, the last node should point to what? It should point to null. So this being the last now latest, because we have deleted that, this will go. In case of C or C++, C++ you have to write delete last. This is mandatory. But in Java, this line is not required. Okay, this is the beauty of Java. You don't have to garbage collect this. Automatically the JVM will do that. Okay, any doubts? Please let me know. So I don't think anybody has any doubts. For the time being, everything is fine. Okay, so let's verify this. Okay, what we did, current dot next equal to null. Now let's go to the main and just call the list dot delete last or remove last, and let's print the list. Fine, let's run this and see what is happening. See, we had 50k plus subscribers, now subscribers is gone. So the first also got removed here in this case, and the last also got removed here in this case. Okay, this is how the add first, add last, delete first, delete last algorithms are working. Okay, got it? I hope you have understood this. Now, as our blue-eyed boy asked this, the question, how to delete the, I think you asked me what? How to delete the middle node, right? Let me check the comment once again, एक second. How to insert the middle of the linked list. ठीक है, let's do one thing. To insert that, we need to find that value, right? Let's see something like this. Try to understand the logic, okay? I need to find the middle, then only I can do it. So, there is a very beautiful algorithm called Floyd's algorithm. And it is also called the hare and tortoise algorithm. And based on this, there are so many questions in linked list. The first question is find the middle node. Find the middle. LE. Second question, delete the middle. Find the middle node, delete the middle node. These two questions are very important. And also guys, there is one more question. Cycle detection in a linked list. Cycle detection in a linked list. These are very popular questions, very important questions, and if you try to understand, these are actually lead code questions. So let me just show you here so that you can also have a look at that. Just one moment. We'll just go to a tab. Just let me open this window and let me just show you here, okay? Middle of a linked list, lead code. See, middle of a linked list. This is the code. Question. Okay, fine. See, interesting question. Difficulty level is easy. Okay. 1, 2, 3, 4, 5. Odd number of nodes, 3 is the middle node. Okay. Even number of nodes, 1, 2, 3, 4, 5, 6. There are 2 middle nodes. Try to understand. 3 and 4 both are middle nodes, but the question says you need to return the next one, the last one. Out of the 2 middle nodes, you need to return the last one. Okay. This is very frequently asked in Accenture and Capgemini. Okay. TCS also asks this, but the point is nowadays TCS does not come to colleges very frequently. Rather, they have their own exam like TCS NQT or TCS Ninja. Directly they will ask the questions there only, and these are very common questions in TCS. Okay, so question is how to find that. Similarly, you have insert in the middle also. So the target is to find the middle. When you find the middle, you can remove that or you can insert at that place. Okay, something like that. Yes, C++ में पॉइंटर यूज होता है, एक ही नहीं, 2 पॉइंटर भी यूज करते हैं. इट डिपेंड्स आपको क्या करना है, इट डिपेंड्स ऑन दैट. ओके, नाउ हियर हाउ टू फाइंड द मिडिल नोड. लेट मी जस्ट शो यू हियर, ट्राई टू अंडरस्टैंड. I'll take both the examples and show you so that you can easily understand what I'm talking about. Any doubts? Anybody? Okay, all good. See, I have 1, I have 2, I have 3, I have 4, I have 5, and I have null. Okay, see what I am doing. I am taking 2 pointers, one called the fast pointer, one called the slow pointer, and both will start at the head only. Okay, slow pointer will move 1 step, fast pointer will move 2 steps. ठीक है, so see this. I'll write while our fast is not is equal to null and fast dot next is not is equal to null, slow is equal to slow dot next 1 step, fast is equal to fast dot next 2 steps. Okay, see what happens now. Fast is also here, slow is also here. Look at the code and try to see. Fast is not null, true, and fast dot next is also not null. So what will happen? Slow will move 1 step, fast will move 2 steps. 1 step, 2 step. Fast comes here. Now second one. Fast is not null, fast dot next is also not null. So slow comes 1 step, fast goes here. 2 steps, 1, 2. Make sense? Next, fast is not null but fast dot next is null. Got it? Now where is the middle node? Slow is the middle node. हमें आंसर मिल गया. देखो 3 is the middle node, right? That's all, finished. This is called the Floyd's algorithm or the hare and tortoise algorithm. Why hare and tortoise? The tortoise is going slow and the hare is going fast. 1 step, 2 steps. ऐसे ही करते हैं इस क्वेश्चन को. Hope you understood this. There are so many beautiful questions on linked list that can be solved using this algo. Okay? कौन सा समझ में नहीं आ रहा है? क्या समझ में नहीं आ रहा है? Tell me. This is a very simple algorithm which you did not understand. Simple pointer logic only. I am taking fast not null and fast dot next is not null. I am just traversing. One is going 1 step, one is going 2 steps. Got it? Let me know if you guys have understood or not. I am just waiting for your comments. ये तो आसान है, ये समझ में आना चाहिए. I hope you have understood this, blue-eyed boy. This is very simple. This is called the, as I said, Floyd's algorithm. Sometimes it is called the slow and fast pointer algorithm. It is also called the hare and tortoise algorithm. Okay? ये फिर से समझाना है. चलो एक काम करते हैं. अभिराम रेड्डी से गॉट इट, नो प्रॉब्लम. अच्छा, ब्लू वाइट बॉय बोल रहा है क्लियर सर, लेकिन फिर भी स्टिल विल डू वन थिंग. लेट अस टेक वन मोर एग्जांपल, द अदर एग्जांपल दैट वी हैव. कोड नहीं लिखूंगा, दिस कोड यू कैन राइट. बहुत आसान है. दिस फास्ट एंड स्लो पॉइंटर्स, टेक दैट टू द हेड एंड यू कैन डू इट. आई एम जस्ट शोइंग यू द लॉजिक. ट्राई टू अंडरस्टैंड द नेक्स्ट वन. विल टेक अनदर एग्जांपल एंड डू इट. ओके, Let us do the same thing for the second one. 1, 2, 3, 4, 5, 6, null. Remember, our target middle node is 6. 1, 2, 3, 4, 5, 6. 4 is the answer, right? 4 should be our answer. So let's take fast and slow. Fast and slow, and write down the same thing. While fast is not equal to null and fast dot next is not equal to null, slow is equal to slow dot next, fast equal to 2 steps, fast dot next dot next. Okay. So fast is not null, fast dot next is also not null. So slow moves here, fast goes 2 steps. Okay. Now fast is not null, fast dot next is also not null. So slow moves here, sorry, here, and fast moves here. Let's take a different color. I'll write slow here, slow, and this is fast. Okay. Okay, I think I have done a mistake here. This should be 2 steps, right? यहाँ पे 2 steps होगा. 2 steps. Fast will go here. Fine. Now fast is not null, fast dot next is also not null. So fast will do what? First slow will come here, slow comes here, and fast will go where? 2 steps. 1 step, 2 steps. Fast has reached here. Now fast is not null, fast dot next is not null, does not exist. This loop is ended. What was our answer? 4. मिल गया आंसर. This is our answer. Simple. अरे कहीं भी लगा लो लॉजिक, काम करेगा. It will work. Definitely it will work. I am telling you, I am challenging. It will work. Can we solve medium once? I have been since the start of the stream. We are going from easy to medium. See, Abhiram, we are not planning to solve questions directly. There are many people who are actually, they don't know the implementation of linked list also. So we are going from scratch. So just because he said how to find the middle of the linked list, I am showing you an example. There are so many examples, okay. We will go to difficult problems. Our target is you can go through the playlist. We are starting everything from scratch and then going to complex problems. So today's agenda, as we see, we are doing actually something like this. Try to understand this. We are actually doing a singly linked list code, and we have implemented the whole code. And yesterday I showed add first, add last. At the same time I had showed, today I showed the remove first operation and the remove last operation. Okay. And then what we have done is we have just seen the implementation, if it is working or not. After that, yesterday I showed the built-in linked list, that is our list interface, how to use that, and also I had showed the array list, and I have also told you the difference between the array list and the linked list. Okay. Okay, and don't worry, you have not been from the start of the stream, that is all good, no problem at all. We are trying to discuss the questions also, and at the same time we are trying to see the implementation also. I hope now you have understood how to solve this question. Anybody in doubt about this question, tell me. I hope you should not be in doubt now after this. We have got the example for both the values. For both of them we got the middle. The answer is at the slow pointer. The slow pointer has the answer. Okay. All good? Yes, Abhiram says great. So actually my plan is to go from scratch. Okay, we are trying to implement a linked list, trying to do the shortcut way by using the collections framework. After that we are trying to solve some problems. That is the target. Implementation, topics, understanding, questions, then the whole topic is done. Then we go to the next topic. That is my target always. Okay, I hope you have understood this. Now I don't think, yeah, Abhiram says great, very good. So everything is fine till now. So one more question, as I said, I want to just show you that. See, this thing you can write your own on your own. If you write that, if you don't get the output, let me know. Submit the same code in lead code, you will get the output. That's my challenge. You can write it down, you will get the output. Okay, just look at the code here, code base, and try to write down the code, you will get the output. No problem at all. After After that, I told you one more algo. Try to remember this, okay? The cycle detection algo. Remember, I have a linked list 1, 2, 3, 4 and 4 is connected to second. Simple linked list, but 4 is connected to second. So, it is something like this. Node of first is 1, okay? Node of, so I am not writing the proper syntax, okay? Don't tell that sir is not writing properly, just try to understand. Second is equal to 2, node of third is equal to 3, node of fourth is equal to 4, 1, 2, 3, 4, okay? Now, first dot next is equal to second, second dot next is equal to third, third dot next is equal to fourth, but fourth dot next is second, okay? This is where the cycle happens. This proves that there is a cycle, right? How to find that? Okay, let's do same logic, the hare and tortoise algorithm, hare and tortoise or the Floyd's algorithm. This is a very frequently asked interview question, okay? Fast, slow, it is the head node, correct? Both are pointing at the head. Same thing, fast is not is equal to null and fast dot next not is equal to null. While loop, slow is equal to slow dot next, fast is equal to fast dot next, 2 steps and 1 step, okay? Let's see, try to understand. After this loop, somewhere if my slow is equal to fast, if they are meeting somewhere, got it? Then there is a cycle, otherwise there is no cycle, okay? Cycle or no cycle, let's try to understand that. So, fast is not null, fast dot next is also not null, so slow will go here, fast will be 1 and 2 steps, fast is here, first time is done. Next, fast is not null, fast dot next is also not null, okay? So, slow will come here, try to understand. Fast will go 2 steps, 1 step, 2 step, fast comes here, okay? Fast is here now and slow is here now. Again, let's try, let's take a different color now. Fast is not null, fast dot next is also not null, so slow will come here, slow is here, try to understand, and fast will go 2 steps, fast dot next is this one, fast dot next is this one. See, did they coincide? Yes, they coincided at the node 4. Cycle mil gaya na, we got the cycle, so return true. Otherwise, return what? False. If they never meet, when the loop ends, return false. Done. I hope you have understood this. Yes, Abhiram, just now I have showed you this, how to check this, the slow and fast cycle detection. Very important question. Hope you have understood this. Got it? Let me know if you have understood this or not. Very simple. Just keep moving 1 step and 2 steps. If they meet at any point, there is a cycle in the linked list. Otherwise, there is no cycle. Is that clear? I hope it is understood. Any doubts, you can ping me in the comment section. I will clarify them. Okay. These are very important questions, guys. So, make sure you practice them. I have given you the, this is actually the pseudocode. I have not written the code. I will write the code. Whenever we are solving problems, we will write the code. No problem at all. Or we can do one thing. We can write this code. Why not? Let's write this code to see if it is working or not. Fine. excuse me. Let's write it down from scratch like this. Okay, create a new in linked list only, singly linked list, and we have not yet started doubly linked list. So here in singly linked list or linked list, right click, create a new package, singly linked list. I'll say what, cycle detection. Yes, Abhiram says that was clear. Thank you. Very good. So you tell me, shall we write the code and verify that? Let's see. Right click, I'll create a new node, right? I need a node, obviously. I need, let's write down cycle detection. Okay, and let's take the node here for our support. Okay, and I need, say I'm taking integers, okay, in data, and I'm taking the node of next pointer, singly linked list, basic idea, and then I will take the constructor node of int data, sorry, I'll say this dot data is equal to data, and next, this dot next will be equal to null pointer. Okay, because initially there are no nodes connected. Fine, something like this. Now what I'll do, I'll write the logic for cycle detection. So public static boolean, true or false, is cycle. Okay, I'm writing like this. Fine, and what do you need? I'll need the head node of head of the linked list. So if it is null, return null. Okay, so if my head is equal to null, just say return null. You cannot return null, so you can return false only. No cycle. Obviously there is only one node. How will you have any cycle? Otherwise, as I said, I'll take a temporary node star slope will be equal to the head. Okay, and I'll take one more node of first will be also equal to the head. Okay, now I'll say while our fast is not is equal to null and fast dot next is not is equal to null, I'm going slow is equal to, sorry, slow is equal to slow dot next one step, and fast is equal to fast dot next two steps. I'll write down a comment. This is one step, this is two steps. Okay, while doing this, if they coincide, if my slow is equal to the fast, you will return true. But if this loop is complete and they did not do anything after the while loop, what I will do is I will return false. Okay, this should be working. Let's see. This is the base code that I have written. Now let's go to the main and create the same thing that I have here. 1 2 3 4 4 dot next is second. Okay, so node of first is equal to new node 1. Okay, node of second is equal to new node, this time it is 2. Let's create all the nodes. Node of third is equal to new node, this time it will be 3. Node of fourth is equal to new node of 4. Okay, and now I'll connect first dot next is equal to second, second dot next is equal to third, third dot next is equal to fourth, and as we need the cycle, fourth dot next is equal to second, just for the cycle. Okay, here let's do one thing. This is where the cycle should be detected. Cycle exists. So what I'll do, this method is returning a boolean, right? So I'll just say if is cycle, pass the head node, sorry, not fourth, pass the head node. Why is it coming like this? Head. I have not written head, right? So it is first actually. Sorry, my bad. So I'll just say S out. Okay. Rather, we can write in a single line only, right? Let's take a ternary operator like this. S out is cyclic, pass the first node and question mark. If it is true, then say cycle colon cycle exists colon cycle does not exist. Let's see if it works or not. In this case there should be a cycle. Let's see what it is printing. See guys, cycle exists. ठीक है? सर आई हैव अ प्रॉब्लम सर, आपने कंस्ट्रक्टर लिए, उसके अंदर इन डेटा को इनिशियलाइज किया, नोड नेक्स्ट को क्यों नहीं किया? क्यों नहीं किया? वेरी गुड क्वेश्चन. पहले बताओ, डिड यू अंडरस्टैंड दिस कोड? वट एवर आई हैव रिटन, पहले ये बताओ. विल गो देयर एंड अंडरस्टैंड दैट लेटर. Have you understood what I have written? First tell me that. Whatever we discussed, we have written here. Cycle detection algo, slow and fast, Floyd's algorithm. We got the cycle. Okay, imagine, see 1, 2, 3, 4 dot next is second. So we got the cycle, cycle exists. We use the ternary operator directly, question mark and colon. All clear? I hope you have understood this. Guys, please let me know if you have understood this or not. Based on that, see, I am looking at the comments all the time. Hope you have understood this algo, the logic. Very simple logic. See, head is null, return false. There is no cycle, only single node. How can it circle around itself? Otherwise, slow pointer to the head, fast pointer to the head, and fast is not null, fast dot next is not null. Slow equal to slow dot next, one step. Fast equal to fast dot next, two steps. Then, if my slow and fast pointer are meeting at a same point somewhere, that means there exists a cycle, and then we are returning true. But if the whole while loop is over and we did not get anything, then we are returning false. Simple as that. Okay? And I have given you live example only. This is the example. Okay? All good? I hope it is clear. Please let me know, guys. I am waiting. After that, I have to talk to blue-eyed boy about this. आपने node constructor लिया, उसके अंदर int data को initialize किया था, node next को क्यों नहीं किया? Very good. Is this clear, all of you? Please let me know. If it is clear, then I know the live streaming will be delayed by at least around 10-20 seconds. So I am just waiting for your responses. So hopefully without any messages or comments, I can see that everything is clear, no problem at all. Now what we can do is, we can try to understand this. What he said in the constructor आपने data को initialize किया, right? And Abhiram Reddy says it's clear. Why do I feel I have heard this name before? Abhiram Reddy. Somewhere, some college where I have been for training, I might have heard this name. And similarly, this blue-eyed boy can be one of my students. Is it something like that? I don't know, I am just guessing. Okay, see, I am initializing this because, see, as soon as we create a node, the node should have some data. Correct? Node के अंदर कोई data होना चाहिए, 1, 2, 3, 4. But initially the node will not be connected to anything. अरे कहीं पे भी connections नहीं होंगे ना. I created one node. See, there is no connection. पता नहीं. We will add later. No connections. The connections I made, first dot next equal to second, second dot next equal to third, third dot next equal to fourth, fourth dot next equal to second. Afterwards I did that. So in the constructor I said that initially the node that we create 1 is pointing to nothing but null. उसका next pointer है ही नहीं. There is no next. It points to null. Then I will point it to some particular value. बाद में करेंगे. Initially null. If you are talking about doubly linked list also, क्या होगा? Initially data, this is the previous pointer, this is the next pointer, ये भी null होगा, ये भी null होगा. Simple. बाद में ऐड करेंगे हम लोग. After that we will add. Initially this will be the node. एक node के अंदर we will have the data of the node. This is the data, and then the next pointer will be null, and the previous pointer will be also null. Because I don't know मैं कहाँ connect करूँ, मुझे पता ही नहीं है. बाद में I will connect later. Okay, I hope this is clear now. And I hope you have learned important algorithm, the slow and fast pointer algorithm, or it is also called the hare and tortoise algorithm. Very important, guys. Okay, so I will just give you a list of all the important questions that you might have from linked list. Okay, let's take it down. I am just checking for any messages. Not yet. All good. Fine. Okay, so everything is fine. There are no messages as of now. Okay guys, is that clear? So this problem has been solved. Similarly guys, please go to lead code and solve these questions according to the fast and slow approach, the hare and tortoise approach. This one, the middle of the linked list, okay, for odd numbers, the middle one is the middle, the second one is the middle, not the first one. And there are similar questions also, similar questions. See, delete the middle of a linked list. Once you have found that, you can just talk about pointers. This is the node, so previous one and the next one you just need to connect them so that the middle one is gone. Previous and next connect together, simple. And similarly, there are lots of different questions. Okay, so what I will do is I will just give you a list of questions. Those are very important. Okay. Fine. Number 1, as we saw, middle of linked list. This you have to find, okay, find, not delete. The second one, middle of linked list. This time you have to delete this, okay. Then this can be done using Floyd's algo. This can also be done using Floyd's algo. Okay. Then there is one more called the reversal linked list. Okay. Then there is one more called linked list palindrome. These are some questions that have been frequently asked in placement drives. That's why I am giving you these questions. Okay. Number 5, reversal linked list. It will be something like this: 1, 2, 3, null. So in this case, 1 is the head. Now it will become 3, 2, 1, null. 1 was the head. Now 3 will become the head. These questions are sorry. This is the reverse question. Okay. This one. This question, linked list palindrome, 1, 2, 1, null. You can see it is a palindrome, 1, 2, 1. from the front and the back it is same. But for a singly linked list, not a doubly linked list, singly linked list palindrome. Okay. So if it is 1, 2, 3, this is not a palindrome, this is false, this is true. This kind of questions. Okay. Then add two numbers using linked list. With what? With carry. You also need to take the carry. Okay. For example, I have 4, I have 5, I have 6 and null, and I have 1, I have 2 and I have 8. Okay, something like this, and a null. In that case 6 plus 8 is 14. So the final list will be 14, 4 will come here, and then 1 carry, 5 plus 2 7 plus 1 8, and then this is a 4 plus 1 5, 5 8 4, and then it is null. This is the question. Okay, got it? This is a very important question. Okay, middle of linked list, find and delete, reverse a linked list palindrome, add two numbers using linked list with carry, and after that this question is also very important. Number 6, yes, we have learnt merge sort. Now we have two linked list. Okay, one second, I'll just go up a little bit. Okay, merge two sorted linked lists. Very important question. Lead code, all lead code questions only. You can get them in HackerRank or Geek for Geeks also. So example 1, 1, 3, 5, 7, 9, null. Okay, and I have one more 2, 4, 6 and null. You have to merge them together, but the merged list should be in sorted order. So what will be the output? Let me just drag it a little bit up. Output will be 1, 2 will come here, then 3 will come here, then 4 will come here, then 5 will come here, then 6 will come here. If you see carefully, 1, then 2, then 3, then 4, then 5, then 6, and 7 and 9 are same to same. So they will directly come here, 7 and 9, and then null. This is the final linked list. Okay, these questions are very frequently asked. Okay, yes, I find reverse K groups hard. Definitely we'll do them one by one, don't worry about that. Okay, but my target is always very simple. Once, if you don't understand how to implement a linked list, you have to understand how to implement a linked list properly, then you can easily solve the questions. The questions will have algos. Some algos will be involved in solving the questions. If you know them, then easily you can understand them. Okay, I hope it is clear now. See, just like I showed you hare and tortoise algo or the Floyd's algo, it is used in so many questions. You can see, you can use that. Yes, I had not written one more question, right? Remember, the 7th question will be what? Cycle detection. So one algo we learnt which can help you solve so many questions. Middle of linked list, Floyd's algo, middle of linked list, delete and find both, and then this one, cycle detection, also using that, correct? So one algo you learnt, you can do it in so many interview questions. Got it? And reverse in K groups is not that hard. Okay, it is also simple. The point is, yeah, K groups is, it will give something like this. Say for example, K is 3. Reverse the 3 from the next one, again reverse the 3, like that. We will discuss about that, don't worry. That is why I am trying to going in a proper pace, because the problem what happens is, directly if you jump from easy to hard questions, you will not understand anything. So gradually you should go step by step. That is why I am following a proper method. Be with me in this playlist Try to learn all the things one by one so that you will never forget anything. That is our target. Just like I am standing in front of you and writing the code, you will also be able to confidently write all your codes. See, there will be errors. I also get errors while I am writing the code. You can just chat with the other friends in the chat room and then you can ask them. I get errors while writing the code. It really doesn't matter. You should be able to debug the code then and there itself. That will come with experience. Okay, and those who are actually new to the channel, please, I am telling once again, please subscribe to the channel and hit the bell icon, because that is very important for me to get motivated to create better content for you. Okay, and I hope you have liked this, guys. It's already 8, so I think we can wind up for today. And today we have finished the singly linked list, not with all the implementation. We covered some important interview topics also. Now what we will do, tomorrow we will finish one more concept, that is our this. Let me just go to that code. Yes, this was the one, right? We had done it for remove first, remove last, done. Now we will try to remove a specific value, delete a target element, then we will go to doubly linked list, and also we will be covering some more interview questions. Fine, and then we will learn circular linked list, very important, and then we will go on to the collections framework, very important. Okay, I think by the end of this week we should be able to start and finish collections framework. Let's see. So be with me till now, and thank you for being with me, and thank you for supporting me. For those who are supporting and those who are new to the channel, please like, share and subscribe. Hit the bell icon for new notifications. Okay, thank you guys. So this is Saurav signing off. Till the next time, keep studying, keep practicing, and don't skip your studying. Very important, otherwise you'll forget. Okay, so till the time you get a job, you have to study at least 1 hour per day.